So under game theory, which falls under oligopoly, you must understand that there is a strategy that is going to be that you need to understand. So in a two-player one-shot simultaneous move, each player can choose strategy A or strategy B. So if both players choose strategy A, each player will earn a 400. If both players choose strategy B, each player will earn a payoff of 200. If player 1 chooses strategy A and player 1 chooses strategy B, then player 1 will earn $100 and player 2 will earn $600. If player 1 chooses strategy B and player 2 chooses strategy A, then player 1 will earn 600 and player 2 will earn 100. What is this jargon all about? It is an issue of game theory. Now you must understand that under game theory, there are two options where players in the market will choose either to cooperate or not to cooperate. So we need to come up with a 4-quadrant strategies that will allow us to understand the concept of game theory. So you must understand that there are moments when the players in this market will make a profit or will lose the market share if they choose not to work together. So that is what this narration is basically trying to tell us. So you can see in this question here, strategy A, strategy B is all about understanding when they're cooperating and when they're not cooperating. So we're going to see the payoffs that we're getting here. We're saying that each player will choose strategy A or B. If both choose the same strategy, meaning they are working together, they'll make a profit of how much? 400. All together. So meaning if they cooperate, they all make a 400, which is something good. If both players choose B, meaning they choose not to cooperate, they'll make what? A pair of what? Of 200.
Are you writing something?
I'm just underlining. So
Okay.
Can you see these boxes that I have here? Yes. So there's player 1 and player 2. So we're told that player 1, all right, we need to identify the strategies that each of these players is going to come up with. So let me start with player 1 using the game theory. So we want to organize the payoff table. So we are told that write the above game in the normal form. So to go through it again, we are told that there are two strategies, strategy A or strategy B. So if players choose strategy A, if both players choose strategy A, they'll make a 400. If both choose strategy B, they'll make what? A 200. So if both choose strategy A, so player 1 and player 2 here, if they both choose strategy A, they'll make a 400 here and a 400. Are we together so far? So we have player 1 and player 2. So if they choose strategy A, and this one chooses strategy A, this one will make a what? A 400. And this one also make a what? 400. Is that clear? Choose strategy B, and this one chooses strategy B. They'll make 200 this guy, and this other guy will make what? A 200. Are we together?
Yes.
Making more sense? Yes.
Yes.
Then what else are we told? We're told that if player 1 chooses strategy A and player 2 chooses strategy B, player 1 will make what? 100 and player 2 will make 600. So if they don't cooperate, okay? So if if player 1 chooses strategy B, you make what? 600. And if player 2 chooses strategy A, he will make what? 100. Okay. All together.
Yes.
This box. So player 1, 100. Player 2, 600. Then we're also told that if player 1 chooses strategy B and player 2 chooses strategy A, player 1 will make 600, then player 2 will make 100. This one I was talking about. Player 1 chooses strategy B and player 2 chooses strategy A. Player 1 will make 600, player 2 will make 100. But we're told also here that if player 1 chooses strategy A and player 2 chooses strategy B, player 1 who chooses strategy A will make 100, player 2 will make 600. So player 1 who chooses strategy A will make 100, and player 2 will make what? 600.
600.
All together?
Yes.
All right. So we now go down to dig the questions that are being asked. So number 1, we are asked, write the above game in a normal form. So this is a normal form. 5 marks, just drawing that. All together?
Mm.
Can you remember this? Player 1 chooses strategy A, player 2 chooses strategy A, they make 400, 400. If player 1 chooses
Player
strategy
1.
B and player 2 chooses strategy A, player 1 will make 600, player 2 will make 100. If player 1 strategy A, player 2 strategy B, player 1 will make 100, player 2 will make 600. If both choose strategy B, they'll make 200, 200 each. This is the table in the normal form. Is that clear?
Yes.
Then let's go to the second one. Find the player's dominant strategy if it exists. So for us to identify the dominant strategy, we need to find player 1's dominant strategy and consider how player 1 will move given that player 2 has made a move. So if player 2 takes strategy A and player 1 will take strategy B, it means the payoff will be as follows. So here is just a replica of this table. Okay, we just need to know the dominant. So where will player 1 have a dominant? Let's read the question again. Find each player's dominant strategy if it exists. So who is making more at what play? So to find player 1's dominant strategy, we need to consider when player 1 will make a move and he will obtain a higher payoff. So the dominant move is when player 1, okay, chooses strategy B, whereas player 2 chooses strategy what? A. So here, the dominant move for player 1 because it's going to make more than player 2 will. So this is the dominant move. So meaning player 1 will play strategy B to obtain 600. So this is dominant move for player 1. You get it right?
Yes.
So which one now is the dominant move for player 2 in this case?
100 and 600.
Good. Yeah. So this is dominant for what? Player 2, where player 1 will player one will take strategy A, which gives him 100, and player B will get 600. So this is a dominant move for player 2. So the strategy that will give okay. So the next question, what is the next question asking us? Find the Nash or the equilibrium. The Nash or the equilibrium. So to calculate the Nash or the equilibrium, it is simply to consider a point where both will cooperate or not cooperate. Okay. So if player 2 picks option B and player 1 picks option B, they will both obtain a 200. All right. So question is, what is a Nash equilibrium? What is a Nash equilibrium? Do you understand what a Nash equilibrium is? So in game theory, when I talk about a Nash equilibrium, it's simply a concept which describes a state in a game where each player knows the strategy that will be taken by the other player, but takes no incentive to have a natural change or strategy. In other words, it's a set of strategy where no player will improve their outcome independently by changing their strategy, assuming other player strategies remain unchanged. So to understand the Nash equilibrium, we can consider the story I gave you of a prisoner's dilemma. In this game, there are two individuals who are arrested for a crime, and each prisoner has two options: one to cooperate, the other one to remain silent, or to betray the other one by testifying against them. So the possible outcomes are associated with the game theory. So there are options here that are available, where if both players will cooperate by remaining silent, they each receive a moderate sentence. If one player cooperates while the other betrays, so the betrayer will go free, whilst the one cooperating receives a severe punishment. If both prisoners betray each other, both will receive a moderate punishment. So in this scenario, Nash equilibrium occurs when both players choose to betray each other. They don't cooperate. So this is because knowing that each prisoner's strategy is to betray. So we're going to look at the point where in this box, if they cooperate, they will both make something moderate. If they don't cooperate, they're betraying each other here. This is what we call the Nash equilibrium. So the Nash equilibrium is simply a point where player 2 chooses option B and player 1 chooses option B. They get a payoff of what? 200. So this is called the Nash. So since player 1 will play B regardless of what this player will take. So if they're going to get B and this one get a B, this will be a dominant. The highest it could make is 200. So to find player 2's dominant, we need to consider player 1's move. So here we did the first one to find the dominant for player 1. It was in this box where we know the move that player 2 is going to make. So we're going to dominate in here. To find the dominant for player 2, we chose this one here because here player 2 is making a 600, whereas player 1 is making only 100. The Nash is where they don't cooperate. Is that clear? All right. Then rank the strategy that pays by aggregate highest to lowest. I think this is what I was trying to explain. Okay. From highest to lowest, so we're going to put them in strategies. So we're going to get the cells here. So cell AA is giving us what? 400 against 400. Add them, which is 800. Cell AB is giving us 100 plus 600. BA is also giving us 100 plus 600, which is 700. And the last cell is giving us what? 200 plus 200, which is 400. So ranking them, we have AA, which is the highest, then AB and BA, which are equivalent, then BB. That is how we rank them in terms of the payoffs. Okay. So the last part of the question was asking us to calculate, can the outcome with the highest aggregate payoff be sustained in the equilibrium? If not, why? So can AA be sustained in the equilibrium? And if not, why? So the outcome with the highest is AA. It cannot be sustained if player 1 chooses A and player 2 chooses B. Or if player 2 chooses A and player 1 chooses B. So the outcome with the highest is AA. It can not be sustained if the players choose different strategies, in short. So this is how game theory is supposed to be answered. And this will be an option. This will be a compulsory question. So I have explained this question in the way it's supposed to be. So what other topic would you want to look at? This one, you understood it, right? Can we look at the Kuhnert? So regression analysis basically is used to see the relationship that exists between two variables, X and Y. So here we have 1, 2, 3, 4, and 5, for instance. Then here we could have 1, 1, 2, 2, and 4. So basically, you're trying to measure the impact that advertising has on sales. Okay, you can call this X and Y. So we'll be asked to come up with a regression equation and also to predict what kind of sales we're going to have for an advertising budget. So here, firstly, we need to expand this. Here you have XY. Here we have X squared and Y squared. So can you help me expand there?
Just hold on. 5, 1. X, Y, 1, 2,
1, yes, 2,
6,
6.
8,
Mhm.
20.
Then here,
Then X squared is 1,
uh-huh,
4,
uh-huh,
9,
uh-huh,
16, 25.
correct. And here,
1, 1, 4, 4, 16.
Good. Then the totals.
1, 2, 3, 5, 6. X summation X is 15. Summation Y is 10. Then summation X square. Which one is this one?
XY.
Summation XY is 37. Summation, wait. Summation X squared is 55. 26, summation Y squared is 26.
Correct. So we can find now the sum of squares. So sum of square XX. I don't know if they're going to remember this. Summation of x squared minus summation of x to the power 2 over n. What is x squared? 55. Summation of x is 15 squared. The n is 5 there. I mean, are they 1, 2, 3, 4, 5? So n is 5.
So this is SS.
XX. Yeah, sum of square XX, just on the x's alone. You're putting x there. So here you're going to 55 minus 45, which is 10. Okay, then we go to SSYY. We just put y's alone. Summation of y squared minus summation of y to the power 2 over n. So what is our y? 26. What is y, small y? 10 squared over 5. So here this is 26 minus 20. What do we get? 6, all right?
Just wait. 26 minus 20, right? Okay, yes.
Then xy, let's put xy on both sides. So x and y over n. So what is our xy? 37.
XY is 37.
Then you have 15.
15
and 10
times 10
over 5.
over 5.
So here we're going to have what?
15 times 10 is equal to 150 over 5, 30. 37 minus 30.
Which is what? 7, right?
7.
Okay. So just a quick recap. What is our XX? 10, YY, 6,
6.
XY, 7, all right?
7.
So SS is what? Is what?
XX is 5. 10.
10. YY?
6.
And XY? 7, right?
7, yes.
Okay. Our summation of X was what? Was
15.
15. Summation of Y was what? 10.
10.
And our N was what?
5.
5. So to find the B, it is XX over, it is XY over XX. So this is 7 over 10. This is 0.7. Okay.
So we don't use that other formula for B1 N is equal to summation XY less X times Y.
This one is shortcut, it's the same thing. If you want to get b is equal to n summation of xy minus
Okay.
here, what we're doing is simple to just simplify here with here.
All right. Okay.
All right, so if you're comfortable with that one, we can do that one. If you're comfortable with this one,
All right.
any of them. So this is a shortcut
Okay.
for that one. So our
Okay.
E is that one. Our A is summation of y
Y
over n
plus
minus b summation of x over n.
n.
So here we have what?
Summation of y is 10
Yeah.
over 5.
Minus 0.7, 15 over what? 5.
5.
We have 2 minus 0.7 times 3 is negative 0.1.
3.1.
So our regression equation is y is equal to a plus what? b. So what is our a? Negative 0.1 and b 0.7, and put the x there. What is our regression equation? And they ask you find what? Y if x is 10. So where there is
X, you replace it with 10.
correct. So we're going to get our y is 6.9. Okay. And they ask you find the coefficient of correlation.
Find the what?
Coefficient of
Coefficient.
correlation. So it's given R is equal to what? S xy
X.
over xx times what? Yy. So our xy was 7. Square root. Our yy was x was 10. Our yy was 6. So this is 7 over square root of 60 to give you 0.903. So for coefficient of correlation, you get the direction. If you get a positive, it's positively related. If you get a negative, it is negatively related. So R is called the coefficient of correlation. Tells you the relationship that you have between X and Y. Okay. How to get? All right. Okay. Then we go to coefficient of determination. We just square that answer we got. R squared or R times R. So 0.903.
Times.
We get 0.816. So this means 81.6% of Y is because of X. That's what it means. If Y is our sales, means 81.6% of the sales are as a result of advertising. Okay? So R squared coefficient of what? Determination.
Determination.
Yeah. What if we got 0.9 means 90% of Y is because of X? Are we together?
Yes.
So let's go to the exam question itself. The same principle is what we use in this question. So here we do X and Y. So we need to identify which ones are X and which one is our Y. Okay. So these ones we swap. Our X is this one and our Y is the cells. So you need to know your determinant and your okay, which one is your dependent variable and which one is your independent variable. So this is our X and this is our Y. All right. So you enter them, then you generate what? The table that will estimate the coefficients of the correlation. So in that table, you're going to find the regression equation. So generate a table that will help you. So you generate that table, then estimate the regression model between advertising and sales. Be careful to interpret the coefficients. So if you have a calculator, you can also use the shortcut for calculator. Do you know how to enter them in the regression mode? Are you there?
No.
Yeah. Mm. Okay. So I will ask whether you have any questions here. During the table I've told you to just swap X and Y because you need to know which is dependent and then estimate the regression equation. If advertising was 220,
Close to 2.
so meaning after getting the regression equation, you've chosen the 220, right? So what inference would be drawn from the analysis? So you get your R and your R squared. So you must also understand that the regression equation also will tell you whether the relationship is positive or negative. If your gradient was a positive, you know that they're positively related. So if instead you increase your sales to 1,500, how much advertising would you need? So now here you swap it. Where there's Y, you put 1,500. Then you find X. Can you fail to get all the 5 marks here?
No.
So all this is straightforward, isn't it? Yeah. Unless you want me to repeat what I said or to take you through the calculator method.
I think I'm okay.
Yeah, okay. So you can choose any other topic now for free, which you need from the topics or the papers.
I don't know which other one is critical that can come.
Okay. So you should also expect questions that are to do with markets and analysis where you need to interpret. So not all the questions will come as easy as just calculations. Calculations are good if you know, and theories also are good if you know what you're doing. So I'll pick one question that has some analysis in it so that I can explain some principles. Let's see. Did you understand the Cobb-Douglas theory yesterday?
Yes.
Okay. So and did you understand how to fill in the table?
No.
All right, so let me take you through production. So we're given the labor units 1 up to 10, the total output, these figures. So marginal product is simply the difference between the total output. So the first one is usually a dash. Okay, because it does nothing. So it is 2 minus nothing is nothing. So 6 minus 2 is 4. 16 minus 6 is 10. 29 minus 16, 18. 43 minus 29, 14. 55 minus that is this. 58 minus 55 is 3. 60 minus 68 is 2. 59 minus 60 it's -1. 53, 56 minus 69. So you understand this column, how we're getting the figures?
Yes.
An average product is simply the total product over labor. So we're dividing this divided by that. So 1 divided by 2 divided by 1. What do we get?
0.5.
It's 2.
Yeah.
6 divided by 6 divided by 2.
3.
This person was swapping or dividing opposite, right?
Yes.
By 3. Please don't make that such a mistake.
5.3.
Right? 5.3. Then and so on and so on. All right. Okay,
Divided by 4.
we get it. So try to get together. Okay. So elasticity of production is also known as the output, elasticity of output. It is simply the change in output over the change in input. So the formula is simply the percentage change in output divided by percentage change in input. So the input here is the labor. So if we want to calculate the elasticity of production, we are just going to find 6 minus 2 over 2 divided by 2 minus 1 over 1. In short, it is our marginal. What is 6 minus 2?
4.
Divided by 2? 6 minus 2 is 4 divided by 2 is
2.
2.
2.
What is 2 minus 1?
1.
Divided by 1 is 1.
1.
So here elasticity is 2. 16 minus 6 is 10.
10.
So in short, you're getting this answer divided. So 4 divided by 2 is 2. 10 divided by 6 is what?
1.6.
1.6. Then 13 divided by 16. So this is how you get the elasticity. The diagonals, just. Okay. 4 divided by 2 is 2. 10 divided by 6, 1.6. 13 divided by 16, you get that. 14 divided by 29. So these are the elasticities. So for this table, you're going to get 5 marks.
So for marginal product,
Mhm.
we're subtracting this minus this is 1. 0 minus 2 is 2. 2 minus 4 is 2 minus 4 minus 2. 6 minus 2 is 4. 16 minus 6 is 10. Then for average, we are, what are we doing? We're dividing
Output over
quantity,
over.
labor. 16, this is, hey. Then for elasticity,
yes, divide 4 divided by
okay, 4 divided by 2,
10 divided by
10 divided by 6, 13 divided by, I hope I don't get confused.
Okay.
Within what ranges do we see increasing returns, decreasing, and negative returns?
So increasing returns to scale is where these output are increasing. It's increasing from what? unit 1
2,
up to unit what? Unit
5.
5, yes. So this is increasing, it tends to scale. Okay. Then constant returns to scale, or decreasing returns to scale is from what? 12,
5,
from 6 to what?
6 to 8.
6 to 8. This is decreasing returns to scale. Negative returns to scale is from 9.
9 to 10.
Yes. Remarks for that. Right.
Consider the following.
So comment on the elasticities found. So elasticities, you discover that they become negative as you go into the there. So here, this variable that. So we have negative elasticities from 9 to 10. Then here we have so it is elastic when we are increasing returns to scale. It is inelastic when we are decreasing returns to scale. Then it is an inverse negative elasticity when we are in negative elasticity to scale. So when we find these ones, you're able to see. All right. So consider the following production function. Q is equal to 6L plus 0.4 L to the power 3. Okay. Find the value of L that maximizes production. So what are we given? 6L squared plus 0.4 L3. So we're given Q is equal to what? 6L squared plus 0.4 L3. Is it? So
is it where we derive?
yeah, so we're being asked to find the value of what L that maximizes output. Okay. So what do? We differentiate and equal to 0. So the Q over the L. Marginal product of
0.4 K, isn't it K? Is that L?
L.
I think it's K. Oh, okay.
It's L. Throughout. Okay, so here what are we going to get?
12 L
plus 1.2 L squared. And we get to 0, right? So we have, what are we going to have? We can factor out a what? What is common? 12 and L. We can factor out 1.2 and L. You're going to remain with what? 10 plus, or we're going to remain here.
I'm confused. What have you done?
I'm just factoring out. Okay, let me simplify this for you. When this one goes the other side, 12 L is what? 1.2 L squared. Is this better? Negative. So we divide by L on both sides. And we have what? 12 is what? Negative 1.2 L. All together. And we divide both sides by negative 1.2. Negative 1.2. So L is going to be what? Negative 10. All together.
Yes.
So to maximize labor, our L will be what? Negative what? 10. Is that okay? So I was trying to use another method, but if this is okay, that's fine. Then find the value of L that maximizes the marginal product. Here, that maximizes output, but here, that maximizes the marginal product. So this is the marginal product. We differentiate the marginal product first, then we get to 0. Okay. So let's differentiate this one. What is our marginal product? Marginal product of labor is what? 12L plus 1.2 L squared. So to maximize, we differentiate once first. This will be what? 12 plus 0.4 L. And we get to 0. So when this one comes there to be 12, let's go to 2.4 L negative. Then we divide both sides by 2.4. 2.4. What is our L?
Negative. Isn't it negative 2.4?
2.4 into 12, what do we get?
What divide the negative 2.4 or 2.4?
Negative 2.4.
Negative 5.
Negative 5. Although in reality, this question was not very correct because here it was supposed to be a negative here. You don't have negative labor. Yeah, but anyway, you're getting the concept, right?
Yes.
Okay. Then find the value of L that maximizes the average product. So let's find the average product. Average product is simply Q over what? L.
Yeah.
It's an average product of labor. Then we differentiate it. So what is our Q? Our Q was what?
6.
Q was 6L squared plus 0.4
L to the power
6L squared plus 0.4 L to the power 3. We divide by L throughout first of all. So this will be what? 6L plus 0.4 L squared. Then we differentiate once. This will be 6 plus 0.8 L.
0.8 L.
So when this one comes aside, it is 0.6 L negative is equal to what? 6. So divide by 0.8 over 0.8. So our L will be what? 6 over 0.8 negative. What do we get?
Negative 7.5.
Negative 7.5. Okay. All right.
This is Q.
All right. So you get it. All right.
I hope I'll be able to remember.
Yeah, you should, you will. All right. So this is where we end. Unless there are any questions.
No. Colin, so you don't even know the 2 tips that are coming.
Okay, so if you have a question under production like this where you're asked to discuss the marginal rate of substitution with practical examples, how do you answer such a question? So this is how you can answer a question like this one. So marginal rate of substitution is a concept in economics that is used to measure the rate that a consumer is willing to trade off one other good whilst maintaining the same level of satisfaction. So MRS represents the amount of one good that a consumer is willing to give up in exchange for an additional unit of another. An example we can use is units of pizza, for instance, and additional units of a drink like soda. So assume you are Debonaires and currently has 4 slices of pizza and 2 cans of soda cream, and their satisfaction or utility is at the same level in that combination. So for you to get more or additional cans of soda, you need to give up 2 slices of pizza whilst maintaining the same level of satisfaction. So this will be at a margin rate of substitution of 2 to 1. So this means that giving up 2 slices of pizza will be equivalent to getting 1 can of soda. So this represents what we call the marginal rate of substitution, which is a trade-off that you, the consumer, will be willing to make between pizza and soda. So suppose we're going to assume 3 slices of pizza and 3 cans of soda. So in this aspect, you're giving up 1 slice of pizza for 1 additional can of soda. So here it means the margin rate of substitution is 1 to 1. So this indicates that the consumer is now able to value 1 slice of pizza to 1 can of soda. So use what is easy for you, maybe 3 to 3, so that you don't get confused. So this is how I could explain that. Is that clear? Is that clear? All right. So discuss the usefulness of the methodology in question to firms in real life. So discuss the usefulness of what methodology? Margin rate of substitution to firms in real life. So how can you give an example of that to any firm that you know? So margin rate of substitution is real. It's a primary concept that individuals and firms who actually use in real life will actually measure what is called the marginal rate of technical substitution. So I'll give you a few examples in which marginal rate of technical substitution is applied either in firms that produce or in firms that are in service. So here is how I could outline it for you. So number 1, in production, for instance, at Coca-Cola Zambia, marginal rate of technical substitution will help determine the most efficient combination of inputs to produce a given level of output. By calculating marginal rate of substitution, firms will identify the optimal input mix that will minimize costs whilst maintaining a desired level of production. So it assists in making decisions about resource allocation. Number 2, marginal rate of substitution is going to be important because it will help So it also helps in cost minimization. So marginal rate of substitution helps in cost minimization. So when firms want to minimize their production costs while achieving a certain desired level of output, MRS, firms will identify at least the least cost way substituting one input for the other whilst keeping the level of output constant. So using MRTS, firms will make informed decisions about input substitution. Then isoquant and the production possibility. So MRTS will help firms determine the shape and slope of the isoquants, which represents different combinations of inputs that will yield the same output. So when MRTS is negative, of an isoquant, it means to give information that the trade-off between the firms is inverse. So this information will be useful to identifying the limits of production possibilities and to evaluate the different production strategies. Then lastly, technological progress. MRTS is particularly very relevant to firms who want to introduce a new innovation. It helps them understand how the new innovation will affect the substitution possibilities between inputs and the impact it has on production efficiency by analyzing the MRTS. Are we together? Okay. So we can pick on another theoretical question that we hope us at least understand some of the questions that may come. So let me go to a different paper. Geoeconomics.
I hope I won't confuse myself.
Okay. So you see these questions are almost similar. There's production, there's electricity. Okay, so I think I'll end here. I've mentioned much of the stuff. These elasticity, I already explained them. Yeah. All right. All the best in your paper.